Okay. Good evening, all. Uh, okay. Good evening, all. Welcome to the ATAL FDP Converging Technologies 6G AI and Quantum Computing for Smart Innovations. Just I'm waiting for the participants. Now it is up to the vertical mark. I will start with a what you call respected honorable principal sir, Dr. Amol sir, and respected our HOD ma'am, Dr. Ankita Karale, as well as our esteemed expert speakers, faculty colleagues, research scholars, industrial professionals, and dear participants. It gives me immense pleasure to welcome you all to the AICTE Training and Learning ATAL Faculty Development Program on the title Converging Technologies 6G AI and Quantum Computing for Smart Innovations, being organized by the Department of Computer Engineering, Sandeep Institute of Technology and Research Center, Nasik, which will be going to held from 8th of December 2025 to the 13th of December 2025. I'm requesting to all that please open your video also, camera, so it will be easy to deliver each and everything. Please, I'm requesting all participants once a while. Please just switch on your cameras. Now, this FDP bring together leading experts from industry, academia, and research organizations to explore the rapidly evolving technological landscape. I'm requesting the all participants just mute your sound. This FDP bring together leading experts from industry, academia, and research organization to explore the rapidly evolving technological landscape as highlighted in our brochure already, which is there in brochure. This program features 13 technical sessions delivered by distinguished resource persons from reputed institutions and industries across the country. Their expertise span 6G intelligence connectivity, AI-driven network quantum fundamentals, digital twins, metaverse, network slicing, QML, and several other cutting-edge domains. The objective of this FDP faculty development program is not only to enhance the technical knowledge but also inspire innovations, interdisciplinary thinking, and future-ready skills. With the emergence of 6G AI and quantum computing, the world is witnessing a significant shift toward automations or autonomous intelligence and hyper-connected systems. So this FDP, we aim to equip participants with insight and tool required to contribute effectively to these technical transformations. I extend my heartfelt thanks to the AICT ATAL Academy for granting this opportunity and our respected chairman sir, Dr. Sandeep Jha, and academic facilitators Professor Pramod Karole sir for their continuous effort. I also thanks principal sir as well as HOD ma'am The organization committee, the technical team, and all faculty members who dedicated effort have made this activity possible. To all participants, I request your active involvement through these 6 days. Your interaction and enthusiasm will make this program meaningful and enriching. I'm confident that the knowledge you gain here will empower your teaching, research, and professional journey. As per today's program, now I request my HOD ma'am, Dr. Ankita Karale, to kindly deliver the welcome address, ma'am. Ma'am, please, HOD ma'am.
Yes, sir. Thank you so much. Good evening to one and all. To all the esteemed faculty members, my dear colleague, all the participants, I, Dr. Ankita, Head of Computer Engineering Department, SITRC, would like to extend my warm welcome to each one of you for gracing the today's inaugural ceremony of this FDP program sponsored by ATAL. On the topic that is the converging technologies on AI, quantum computing, as well as 6G for smart innovation. This FDP will provide us a vital platform for explore the innovation, sharing knowledge, and adopting the solutions. Our SITRC, as you all know, it is the Sandeep Institute of Technology and Research Center, is a reputed autonomous college situated in Nasik under the flagship of Sandeep Foundation in the lush green campus of 350 plus acres. We are known for providing the quality education along with the world class facility. Our computer department, which is established in 2008, it is the prominent department in SITRC with having the remarkable intake of 180 seats, which is accredited with the National Board of Accreditation 2 times. We are known for our top notch placement because here we are committed for providing the industry ready standards to the student. Our main focus is on the practical learning as well as on the industry ready curriculum, and that is the result for most of the students in Maharashtra. Our college is the dream destination, and when it comes to the industry ready technology, not only for students but also for the faculty members, it is very much important to upgrade themselves. That is the purpose of this FDP. That's why I'm very much thankful to the Professor Vase sir and our associate professor Dr. Naresh sir, who are the coordinators of this FDP, for taking all the efforts and arranging this FDP. I'm also thankful to our principal sir for providing this opportunity. I'm also honored and thankful to the ATAL also for AICT too for giving us opportunity to host this FDP. And I'm again welcoming you all, again calling you for taking this opportunity, for this learning opportunity. Just explore yourself and give us a feedback that we are going on the right path or not. We are expecting that you will take the advantage of it. And thank you so much for taking your valuable time. I don't want to take much of your time because I know you have a long schedule throughout the day, and this is the second inning. You are still here with the large number. I'm thankful and keeping you the all the wishes. Thank you so much. Vasi sir, you can continue further.
Thank you, ma'am. Thank you very much, ma'am. Uh, thank you, ma'am. Thank you very much. Once again, I warm welcome you all. Let us begin the FDP with great energy, collaboration, and shared vision for the innovations. Just today, for today's session, we have two what you call expertise. I'm welcoming the Dr. Vijay Nalamuthu. I hope so, sir is already joined. Sir, Dr. Vijay Nalamuthu is there?
Hi, sir. I'm available.
Yes, sir. Thank you for joining, sir. Dr. Vijay Nalamuthu.
Welcome, sir. I would like to welcome you on behalf of SITRC for the today's FDP. You are the opening batsman for this, and wishing you all the success for this.
Thank you, ma'am.
Just a small introduction is there. Dr. Vijay Nallamuthu is a senior consultant of Deloitte and expert in the data analytics, as well as artificial intelligence and machine learning, with overall 17 years of combined academic and industry experience. He is special in data-driven decision making, analytical modeling, and emerging AI technologies. Dr. Vijay Nallamuthu is a sought-after resource person, keynote speaker, and expert trainer, delivering vertical workshops, FDP, and talk at reputed institutions and international conferences also. He holds a PhD in computer science and engineering and multiple industrial certificates also, including AWS Cloud Partitioners and what we call alert YX design credentials also. So once again, welcome, sir. Over to you, sir. It is your up to you, sir.
Yeah, thank you, one and all. So first, I will share my screen.
Okay, sir. I will give you the 1 minute, sir.
Yeah.
Now you can share it.
I hope my screen visible. Can anyone confirm?
Yes, yes, sir. Your
Yeah.
screen is visible.
Yes, sir. Okay. So first of all, thank you, the participants who are joining this FDP. I hope morning onwards you are working, and this is the second level working. I hope this is the very difficulty, I know, to learn with these things. So based on your interest only, I hope you are all interestingly to join voluntarily. Thank you for all the participants who are all joined. And for this given opportunity, the college principal, Sandeep College principal is Dr. Amol sir, and Dr. Angita madam, HOD, and Dr. Muhammad Abdul Wase, coordinator, and Dr. Naresh sir, co-coordinator. So thank you for giving this opportunity. Okay, we'll start the session quickly. So today's topic is mainly 6G vision and architecture from terahertz to the intelligent connectivity. So while exploring the 6G, it's a difficulty to learn this one, but we'll try to we'll try to explore the 6G vision and architecture, how it is intelligently to working with terahertz data. So nowadays we are using with the gigahertz. So, but we can go with the terahertz with the quantum computing also. So mainly for today, we are going to explore with the world will look like when the mobile networks become extremely smart, not just fast, but intelligent. So mainly the 6G technologies is behind it, why it is going to be a big change, like how the smartphones changed our lives. So mainly the smartphone, if we see with today's world, how it is drastically changing with the network. So 5G has today's fast internet, but there are some limitations because of while implementing to the quantum computing. So we require more demand. So based on the demand, we require the terahertz connectivity. So 6G as a network that can think and predict what you need before you ask. So that is the motto we had to go with the 6G. So let's begin to the session. So introduction and objectives. So first session, the introduction is mainly, as I mentioned with the these points, 2 points, 6G as the network, so that can think and predict. So These are all the session introduction points. So session focus, 6G vision and evaluation, session objectives. These are all. So the session objectives. So in this 1.5 hour session, I'm delivering these objectives we can go. So like mainly evaluation of the networks and 6G vision and architecture and terahertz waves. So main thing is to terahertz waves. So how this enabling the technologies like discussing the converging technologies such as terahertz communication and AI native networking enabling 6G capabilities. So these are all things. The main important key focus area is this one. And research and applications. So that already R&D is to be started. You're all with writing the papers and articles, many of them. So just we'll touch up with the research and applications last 10 to 15 minutes, and we'll go ahead. So why 6G matters and its role in AI. So why do we need 6G? So 6G is required mainly the limitations of 5G. So 5G is why 5G limitation called as mainly the demand. So day by day the demand is growing. Okay. So based on the demand, we had to provide with the real time and different intelligent and immersive experience applications we had to use. So upcoming applications require a level of performance that 5G cannot fully support. So based on the demand, we are expecting the more applications. Okay. So example we can take as mainly holographic calls or autonomous robots and drones, massive IoT and digital twins. So these are all some applications we can use in the day by day. For example, we'll take in as a holographic calls, like 3D calls we can expect. So autonomous robots and drones we are using. So day by day, the drones are everywhere in every scenario we are using with the drones. In agriculture field, we are using the drones, and whereas in the camera field, camera and video purpose, we are using most every scenario we are using with the drones. Okay, so this is the 6G technology goals and transformative the potential. So why we are using with the 6G. So the role of AI in 6G called as mainly the role is like AI native networking. So AI native networking is mainly 6G integrates AI at every network layer, making AI essential rather than the optional. Or not only the network optimization. So optimization called as mainly, for example, like we can take in as the when you walk from one building to other building. So sometimes we have the call dropping. So what 6G is to be taking care of the network call drops are drastically decreasing. So drastically, why how it is decreasing called as the AI is implementing. So while implementing the AI, so the network is to be rerouting automatically. The traffic is to be congesting, optimizing the traffic. So wherever it is required to, it is automatically rerouting the traffic. Enhanced security, context-aware connectivity. So these are all the role of AI in the 6G. So quantum technologies and convergence. So this 6G and the quantum technologies mainly will improve the quantum computing is mainly to improve with the 6G connectivity. So quantum computers are mainly to optimize the traffic. So how it is optimizing the traffic called as mainly, for example, network self-healing. So for network self-healing, AI automatically reroutes the traffic like Google Maps. So it is automatically to rerouting the traffic and coming to security and anomaly detection. So this security also AI can detect unusual behavior like cyber attacks. So today's we've seen many of cyber attacks are attacking. Okay, so this we can reduce by using the 6G plus AI plus quantum technologies. So 6G and quantum technology is called as mainly so anyway, this is the completely different we say completely different of the quantum, but here the scenario is we can implement as the 6G plus AI plus quantum. So how the quantum is to be affecting with this one? So quantum computing optimization, enhanced network security, integration, so boosting the performance. So these are all the resource allocation, quantum communications, KDs. So QKD called as quantum key distribution and quantum safe encryption. So these are all to ensure with the 6G connectivity. Okay. So how the converging technologies implementing. So how it is managing the bigger impact. So the bigger impact is mainly 6G as a backbone of the network. So 6G will enable the real-time computational offloading and intelligent edge services for hyper-connected devices, etc. So integration of emerging technologies, 6G converges with the AI, quantum computing, edge computing, and IoT to create unified digital ecosystem. If we create with one ecosystem, so these are all the integration of the technologies is to be required. So while implementing quantum computing is not only the uh, it's one technology implementing is not sufficient. So we can integrate with AI, 6G plus quantum computing plus edge computing plus IoT to create a unified digital ecosystem. So enabling smart innovations. So smart innovations is mainly we can implement this in the smart cities. So example, if we can take as the smart cities, so like traffic controlling. So based on the AI, we can integrate with the AI to rerouting the traffic. So it's optimizing the traffic control, healthcare, autonomous mobility, and industry 5.0 advancements. For example, industry we taken as human plus robots. So working together in the factories. So using the AI driven, etc. Or else if we consider as the healthcare, so remote surgeries. So remote surgeries using the robots. So this we can implement. So different emerging technologies and enabling the smart innovations. 6G as in the central nervous system. So central nervous system is mainly integrating with the diverse technologies into an intelligent infrastructure. So this is the complete the introduction part about with the 6G and with AI plus quantum computing, how we are implementing. Some first 10 minutes I just taken with the introduction part. So the upcoming topics are what we are covering as mainly mobile network evolution, advanced communication technologies, integration with AI and quantum, research and opportunities. So this is the evolution of mobile networks 1G to 6G. So 1G to 6G, how it is drastically improving. So 6G is yet to implement, but till 5G, how it is drastically improvement, how it is in which area it's not required from G to 6G we can cover. Just I will quickly complete with 1 or 2 minutes how it is implementing this 1G, 2G like. So 1G is like analog voice, like voice calls. So at the time of implementing with landline calls. So landlines are mainly at the time only some voice messages only we can voice calls only we can send at the time. So the first generation focused. And coming to 2G. So 2G is the digital communication and SMS. So 2G made everything as in the digital at the time only to starting with the digital world. to starting with the 2G. And 3G, some mobile internet is to be started, sending the Skype calls at the time. These are all. So 4G drastically changed completely when the Geo is to be introduced with the 4G mobile internet. So 3G introduced with the digital messaging and mobile internet, while the 4G is enhanced broadband speeds, enabling streaming and rich media. At the time of 4G, completely the digital world is to be changing. Entire the digital world is to be automated. So coming to 5G, the ultra high performance. So 5G networks deliver with the ultra high speed, low latency, and massive connectivity supporting IoT and smart cities, etc. For 6G, we are expecting more. So how it is 6G called as? So 5G at the time of implementing, AI is not integrated, but 6G, while integrating with the AI and quantum computing. So how we are expecting our expectations. So our expectations are mainly AI-driven networks. So 6G integrates AI and computation, enabling the predictive and adaptive networking for transformative social impact. So the next topic is, so we can cover as 6G vision and terahertz communication. So this is mainly exploring the future wireless networks and ultra high frequencies. 1 minute. So coming to 6G vision and terahertz communication. So 6G vision and architecture. So 6G vision and architecture is mainly focus on the 6G, what we say, the 6G connection, intelligent connectivity. So these are all we can cover. So 6G vision, intelligent plus hyper connected future. So this is mainly we can say as like a smart environment. So how the smart environment, where devices, people, machines, and the digital worlds, so these are all connecting intelligently. So how it is effectively working with this one. So example, let's take as holograms. So holograms that appear in the real time are AR, VR, augmented reality or virtual reality. This virtual reality classrooms where students and teachers interact virtually, or else in the digital twins of factories, hospitals, and cities, updated every second. So these are all we are capturing. So like these some examples we can say, and we can say as like 5G. So 5G is like a high-speed car. While assuming with the 6G, 6G is an autonomous smart car. So for smart car, things like senses and drives itself. So mainly 6G is smarter, not just with the faster. So like 6G vision and intelligent. So coming to global 6G vision, ITU, 3GPP, and next uh, G Alliance. So like ITU's 6G vision called as mainly like ITU is like International Telecommunication Union. So this union ITU is it envisions with the 6G as the foundation for smart cities or smart societies, focusing on sustainability and inclusivity in the worldwide. Like 6G must be intelligent, secure, scalable, and ultra reliable. So we can say, so like next G alliance priorities, like hyper reliable, secure, and green 6G networks supporting with the critical infrastructure. So these are all with the maintaining. So while implementing with the 3GPP AI native architecture, so 3GPP is mainly like AI native with built-in sensing. So inbuilt sensing, like sensing to adapt to environmental changes dynamically. Next, key performance requirements of 6G. So what are all the some technical requirements? So technical requirements called as mainly 6G must handle extreme performance, like based on the demand, because the future will have trillions of devices and real-time holograms. So simply we can say as like example, 1 Tbps speed. So for 1 Tbps speed is equal to we can download as like 1,000 movies in 1 second. So with this ultra high bandwidth, we can achieve with. So 6G aims to achieve with the peak data rates up to 1 terabit per second for instantaneous massive data transfer. And similarly, minimal latency, enhanced efficiency, massive connectivity. So these are all we can say as. So like example, we can say as like a future smart city might need billions of sensors, like measuring with the traffic, pollution, health, and energy usage. So these are all we can consider all at the same time, like based on the requirements. For 6G frequency spectrum, so terahertz focus. So terahertz focus is mainly 6G uses very high frequencies like terahertz. So this terahertz frequencies are like laser beams, super fast, but cannot travel long distances unless guided. So mainly 6G uses with the beamforming and RIS. So mainly this RIS called as reconfigurable intelligent surfaces. So reconfigurable intelligent surfaces is mainly to reflect the signals smartly. So and MIMO. So MIMO is mainly multiple input, multiple output to improve the signal directionality and coverage. So these are all we can implement with the 6G frequency spectrum, terahertz focus, etc. And coming to AI network, AI networking is mainly core vision of the 6G. So this core vision is mainly 6G is the first network built with AI inside every layer. So inside every layer is mainly AI will predict with the network load. AI will predict the spectrum to work best with the intelligently, like AI-driven network architecture, self-learning, self-healing, context-aware connectivity. These are all. So how it is working, mainly our expectations called as mainly understand user intent and increase the security by detecting with the anomalies, heal itself when there is a failure, allocate spectrum intelligently. Example we can consider as so, if you start with a video call, 6G will automatically boost bandwidth before you even ask. So if a tower fails, AI will immediately reroute with the traffic. So how it is rerouting the traffic based on the traffic congestion, the AI rerouting to the traffic and enabling with the other towers. Next, we can say as ISAC, integrated sensing and communication. So 6G will sense plus communicate simultaneously. So 6G networks will behave like the radars, like dual function networks, real-time situational awareness, enhanced indoor navigation, intelligent network system. So these are all we can say. So example, autonomous cars detecting with the pedestrians. So these autonomous cars, while moving the car, the pedestrians is to be detecting based on the detection. the sensors are working. And drones. So drones avoiding with the obstacles, robots navigating the indoors, or else you can consider as smart homes. So smart homes detecting with the human presence. So imagine Wi-Fi that can tell you how many people are in the room without cameras or without that, based on the 6G sensing. Then 6G architecture and network of networks. So 6G connects everything like earth, air, and space. So this architecture includes like ground, like towers, fiber, air called as mainly the drones, airborne basic stations, and space satellites, plus cloud native core, powerful edge computing, distributed AI, and quantum safe encryption, some etc. These are all the we require. So some simple message we can take as mainly 6G is like a super network made by combining many smaller networks like ground plus air plus space plus all working intelligently as in the one. So this is called as 6G architecture. And coming to human centric and sustainable network vision. So this human centric innovation is mainly 6G is built for people first, not the machines. The main focus is called as personalized connectivity or reliable networks for healthcare, education, governance, eco-friendly infrastructure, energy efficient hardware, carbon neural network goals. So these are all. So example we can take in as like remote villages. So remote villages getting with the high quality virtual classrooms. Healthcare side we can take as example like healthcare monitoring for in the real time scenarios like so elder persons we can take in as healthcare department, and networks powered by the like solar, wind, energy. So these are all we can say as some examples. It's like upgrading the internet to be not only the smarter but also greener and more human way we can think as like. So 6G aims to improve the lives while protecting the planet. For this next one is the key enablers of 6G. So major enabling technologies of 6G is mainly terahertz communication. So our topic also today's one is mainly terahertz data we are uh, connecting. So terahertz communication is mainly extreme speed. So like terabytes of data we can connecting. So AI native intelligence, self-thinking networks, and RIS, smart surfaces. So this RIS is mainly like wireless networks. So reconfigurable intelligent surfaces are mainly is to optimize the signal propagation in challenging environments for better connectivity. So for this better connectivity is mainly wireless networks we are configuring RIS. And quantum safe cryptography. So quantum safe cryptography is mainly the future-proof security. So protects with the 6G networks against emerging cyber threats. So example we can take as like a digital twin. So digital twin called as mainly a factory can analyze real-time data and prevent with the machine failures. So next to we can see as like terahertz communication. So for terahertz communication, we consider as mainly terahertz frequency bands, advantages of terahertz communication, challenges and solutions, futuristic applications, etc. So this we can see. So terahertz communication in 6G. So this mainly introduction to the terahertz communication is terahertz frequency range. So we can say as frequency range like 100 gigahertz to 10 terahertz. It's extremely fast, so that it becomes the engine behind 6G's terabyte or else TBPS speed. So terahertz allows mainly super high speed data transfer, real time immersive technologies, experiences like holograms, advanced AR or VR. Uh, some simple message called as mainly if 4G is like a bike and 5G is like a car, then terahertz for 6G is like a jet engine. So that way we can take as some small example. So that is terahertz is the core ingredient behind with the 6G's extreme performance. So why terahertz for 6G? So why terahertz for 6G called as mainly we are running out of space in current frequency bands. So the future demands for the uh, holographic communication, full metaverse, real-time digital twins, ultra high resolutions. So like this. So think of terahertz as the opening a massive 20-lane express highway because the old 4-lane road cannot handle for the future traffic. So if you built with the this many lane express highway, the future we can sustainable with the this that fast environment. Okay, so like terahertz unlocks massive capacity and speed. Comes to the frequency band. So this frequency band is mainly lower terahertz to the band applications. So lower terahertz frequencies are mainly 100 gigahertz to 300 gigahertz. So that is enabled with the short range, high speed wireless communication links, etc. So for this the low speed, okay, like lower. So for the mid range called as mainly the mid range is 300 to 1000 gigahertz. So it supports like ultra high bandwidth, okay, like feature AR or VR holograms. For the upper terahertz band potential called as mainly 1 terahertz to 10 terahertz are the ideal for advanced sensing and high resolution imaging applications. So coming to research and innovation, so terahertz bands are under active research, offering opportunities in the hardware design and propagation in modeling innovation. So hardware designing, many opportunities is there for designing this one. Coming to advantages, so advantages are in the benefits of terahertz called as mainly uh, ultra fast, simply, or ultra low latency, high resolution sensing, support for denser environments. So these are all we can say as like advantages. So for simple message called as mainly terahertz is so fast that it can transfer a full HD movie in a fraction of a second. So coming to challenges in terahertz communication. So challenges called as mainly many challenges is there, like major challenges. But this terahertz is a powerful, but uh, like we can say as fragile. So this gets with the absorbed by the air and the moisture, like are very short range. So it works only a few meters, but it works with the effective speed of the network and cannot pass through the walls. Hardware for the terahertz signals is still new, but it is uh, it is designing under the process. So it beams with the must be precisely aligned. So example we can take as like if a person walks between the transmitter and receiver, the terahertz signal may break temporarily. And key enabling solutions. So for key enabling solutions, mainly reconfigurable with the intelligent surfaces like RIS. So RIS is mainly walls become smart reflectors to guide with the terahertz signals. And ultra massive MIMO. So this is ultra massive MIMO is mainly multiple input, multiple output, like hundreds or thousands of antennas to boost with the range. And coming to pencil beam forming. So for pencil beam forming is terahertz beams as like a laser pointers, like highly focused and AI driven beam tracking. So AI predicts where the user is moving and adjusts with the instantly beaming the adjustments. So like AI is predicts our user movement. So these are all the automatically adjusting with the beam tracking for the wireless connections. Coming to reconfigurable intelligent surfaces, RIS. So this RIS is mainly smart surface technology, enhanced signal propagation, wireless network paradigm. So mainly RIS is a game changer for the terahertz. So this game changer called as mainly RIS are the we can say as like smart surfaces. So smart surfaces placed on the walls, poles, or in the buildings. So these are all. So what they can do is mainly to redirect with the signals or to reduce with the signal loss or to we can say as like to improve with the coverage in the blocked areas, turn physical spaces into the communication helpers. So these are all the main the RIS advantages, like how it is effectively working with the RIS. So simply we can say as like RIS turns a normal wall into a smart mirror that reflects terahertz signals into the perfectly. So terahertz for integrated sensing and communication. So like ISAC. So this ISAC is ISAC terahertz for sensing plus communication. So this terahertz waves give extremely accurate sensing. So it can detect with we can say as like tiny movements, like can identify the objects. It works like a radar with the multi like in the millimeter precision. This is all. So this is essential for the mostly drones or in the robots, self-driving cars, indoor mapping. So these are all. So for simply we can say as like terahertz makes the network feel like it has eyes. It can sense. It can sense means the objects are in the nearby. So these are all the advanced applications. So coming to terahertz applications in 6G. So for terahertz applications, the real world applications. So the real world applications are mainly uh, holographic telepresence, like full body holograms, digital twins in manufacturing. So this is updated in the real time. Immersive XR and tactile internet. So this is for immersive experiences to feel with the XR and tactile internet and ultra fast wireless links. So these are all some of the applications in the 6G. So we can say example like engineers can control a digital twin of a factory from anywhere with live updates every second. So terahertz use cases called as industry and research. So we can say as like smart factories. So smart factories called as with microsecond coordination in smart factories or enhancing automation and operational efficiency. These are all. Autonomous vehicle platoons. Autonomous vehicle platoons called as mainly that instantly reacting. So like using the terahertz communication, it supports coordinated with the instance communication and remote surgeries operations like advancing medical robotics and telemedicine. So these are all using the remote surgeries and ultra fast data transfer and AI robotics, like AI driven tools. We can simply tell us. So like it communication seamlessly we can get. So this communication, how it is seamlessly getting called as using the AI driven robotic systems or in the ultra fast file transfers. So these are all. So terahertz plus AI, a powerful combination. So this is a powerful combination called as mainly predictive with the beam steering, adaptive resource allocation, real-time abstraction prediction, intelligent RIS configuration. So these are all we can say as like terahertz networks overcome with the some of the challenges. So challenges and research opportunities. So mainly the challenges called as we can say as um, hardware design for terahertz components, security models for high frequency communication, molecular absorption modeling, AI driven mobility management. So, so these are all some of the challenges and research opportunities. So mainly RIS optimization also. So how it is working with the RIS optimization called as in the challenges. Uh, it's like a smart mirror that redirects with the wireless signals to improve with the 6G connectivity. So that it works with the how it is working. Like terahertz is like a new scientific playground. So unexplored, full of opportunities. Mainly, terahertz will dominate with the research for the next decade. So coming to transition 6G AI native 6G architecture. One moment. So coming to AI native 6G architecture and intelligent connectivity. So this is the next generation networks enabling with smart communication systems. So this is called as AI native 6G architecture. So main thing is here AI native architecture, the core of 6G. So core of 6G is mainly AI integration in the 6G part. So in the AI integration 6G part is uh, like automation part. So automation called as so some of the tasks were in the programmed but in the 6G like AI into the every network layer. So it is enabling with dynamic learning, prediction, and optimization. So autonomous network systems and uh, enhanced connectivity and efficiency. So these are all the core layers of the 6G part. Why AI is the inside the network? So why AI is the inside the network is so mainly these 6G networks will be far too large and complex for the humans. So like manual control. So there is no much manual control in the 6G part. So but that is the difficulty task. So 6G's network is the complexity. So 6G complexity is massive number of devices. Okay. So like billions or trillions of sensors we are working. So nowadays, if you take as one bike or one car, how many sensors are attaching? So like we can expect as in the 6G, how many sensors are working, or if you consider as in the mobile, smart mobile, in the smart mobile, how many sensors are is working in that one. So the same we can expect as in the 6G, how many sensors are working. So there is no manual control in the future. So AI for adaptive control. So this adaptive control is mainly AI enables predictive decision making process and adaptive control to steer with the terahertz beams and allocate the resources dynamically. And it supports for mission critical applications and enhanced reliability and scalability. Coming to AI across all layers of 6G. So these all layers called as mainly like a physical layer. For example, so this physical layer is predicts with the wireless channel and it controls to the terahertz beamforming. How it is working with the terahertz communication, these be optimizing the beamforming. These are all it's working to. So MAC layer. So MAC layer is mainly decides with the scheduling, avoids with the interference and managing the access. So these are all will take care of the MAC layer. And core network management. So this core network management is mainly it predicts with the traffic and managing the network slicing and optimizing the routing and selecting the best routes. So these are all to take care by the core network management. And coming to service layer adoption. So this service layer adoption is mainly AI delivers with the context, aware with the experiences by adapting with the connectivity based. So these are all service layer adoption. Coming to distributed AI and edge intelligence. So this is mainly on-device AI capabilities. So on-device called as mainly like example phone or in the robot. So or else in the edge, so nearby the servers. So edge AI processing data nearby the user to reduce the latency and enhancing the privacy in the real-time applications. So these are all. And coming to cloud AI for the large-scale tasks. So cloud AI manages with the large-scale model training and predictive analytics for scalable performance. Critical role for the in edge intelligence. So think of it like a brain with many brains distributed everywhere. So 6G is an ecosystem of the distributed intelligence. Next, advanced AI techniques and security. So these advanced techniques called as mainly like we can use as a deep learning part. So reinforcement algorithm or else in the for digital twin technologies, AI enhanced security, intent-based networking. So these are all under the deep reinforcement learning in the 6G part. So this reinforcement learning is mainly teaches the networks through the trial and error. So these networks tries actions, sees with the results, it learns with the best behavior. Mainly it is used for the select with the best tower for handover or adjust with the transmission power, choose with the optimal routes or scheduling with the users efficiently. So these are all deep reinforcement learning is taking care. Like a child is learning to ride a bicycle. How the child is to be learning the bicycle? Slow start, then perfect balance, then uh, day by day learning is going on like that. So 6G becomes smarter over time. Next, we can see as the intelligent connectivity in 6G. So how 6G is intelligent connectivity? So for this one, mainly concept and pillars of intelligent connectivity. So this intelligent connectivity is mainly edge. One moment. Sorry, 1 minute. I'm getting call.
Okay, sir.
Okay. Sorry for the inconvenience. I'm continuing. So we are in the covering with the concept of intelligent connectivity. So how intelligent connectivity is mainly like in the example, we can focus with 5G. So 5G is focusing with high-speed internet. How the 6G is focused with this concentration is mainly to shift with the smart internet. So smart internet is intelligent connectivity is mainly the network thinks not just with the transmits. It understand with the user needs in the real time. So what is the user expectation? So based on the user expectation with the effect of AI plus with the effect of quantum, so this understand with uh, the need of the real time of the user. Based on that, it adapts automatically based on your activity or based on your location, based on your application. So it is working. So it merges with the communication plus computing plus sensing plus AI. So like how it is working with this one. Okay. So like it's simply we can say as like 5G is like a fast car, 6G is like a smart self-driving car. So what self-driving car it is? It is automatically adjusting the speed. It predicts with the traffic, and it predicts with the predict means based on the route. What the route is we are giving. So based on the AI optimizing with the route also. So like the best route optimizing called as here in this scenario. So and text with the best route automatically it is going on. So like smart, adaptive, intelligent works. So this is called as predictive networking and resource management. So predictive network is mainly like network congestion. So we can say as in the so uh, simply we can say as like sensing. Like example we can take as doctor. So let's say uh, doctor detecting with the disease. How detecting the disease like in the early stage only the risks we can identify. So based on the risks identifying the doctor and preventing with the illness. So the like the same. So predictive with the networking and proactive with the connectivity also we can identify. So in the early stages only we can identify with the prediction. So like let's say example uh, how the network I think in the computer networks we have this topic is the network congestion, this one. So cryptography and security. So user movement. So user how the user movement, how the components are failing. So before outages only components are we can identify, and environment changes. So before and signal dropping only we can identify with the environment change. So nowadays we know with the once the environment is to be changing automatically the signals are dropping. So in 5G is somewhat better. In the early stages 4G, we can observe with the once the environment is to be in the rainy situation or in the cloudy situation, so automatically the signals are dropping. So, but in the 5G, somewhat better. So more not in the as like as in the 4G. So in 5G is network dropping is very rare cases, and some improvement is there. So in 6G we can expect as in like network congestion, user movement. So these are all environment changes, component failing. So these are all we can predict how it is optimizing with the terahertz and beam steering. These are all coming to integration of sensing and multi-sensory connectivity. So this integration is mainly as I mentioned in the previous slide, sensing plus communication plus computing. So here we can integrate with the multiple things. So how it is working with us, this uh, this multiple things called as, so 6G networks act like as a radars. So like they can detect with the objects, to track with the gestures and like human movement, and identify with the obstacles, sense with the indoor surroundings, improve with VR. So this VR is nowadays we can see virtual reality, uh, best virtual reality is going on. So while implementing with 6G plus AI, better possibility is there. So useful. So this is mainly useful for this sensing and integrating communication is integrating this one. The main use for the robots. If you implement with the robot, so like how it is acting. So the robot. So like we can take as the sensing plus communication plus computing we can include. Then how the robot is effectively working. So that we can see. And like we can say as like smart car, autonomous car. So if the autonomous car also without driving, without driver, how it is effectively is running, that integration with the this one sensing and multi-sensory connectivity. And not only the autonomous cars, even in the smart homes or in the navigation part also. So next thing is the like edge intelligence and smart applications. So these smart applications like local data processing, industry applications, so digital twins and 6G. So these are all. So these smart applications are mainly like autonomous mobility in the healthcare or in the smart cities or in the agriculture or in the industrial digital twins. So many things we can see in the real time. These are all applications of the intelligent connectivity or in the smart applications. Example, let's take as the agriculture. So AI assisted farming. So nowadays in future we can see already they started with the this one. So in future many things we can see AI assisted farming, or else in the industrial way, real time monitoring of the factories. So the factories are they are automating with the sensors. We can check with the it's automatically the factories is running like uh, based on the AI data, or else in the healthcare department. So in the healthcare department, real time remote surgeries in the future. So and smart cities, intelligent traffic. Main thing we can see in the cities, most of the cities, tier 1 and tier 2, the traffic. So nowadays, most of the cities are switching to AI. So how the AI is to be traffic controlling, like intelligent traffic is, so the signals are working with the based on the traffic, like how the effective traffic is So it is optimizing with the AI is optimizing with the traffic, like pollution monitoring, etc. Let's say example like a farmer gets a real-time soil and crop the data from thousands of sensors. So like this one, giving the precise fertilizers and water recommendations. So these are all things we can implement. So next, coming to 6G plus AI plus quantum, we can say as like converging technology. So like the future of technology, exploring the next generation innovations, transforming our world. Okay. So here I'm stopping, just pausing. So audience, any questions we'll take, or else we'll continue with the, our time is I think 7:23. Okay. So another half an hour session is there. Is there any questions we can give, or can I continue, sir?
Dear participants, if anybody have any questions, you can ask the question with the experts. If you have any questions, write in chat, or you can request I will open the audio.
Yeah, because this is the interaction session, but it's a new technology. Today's is the introduction session. So I have stopped after 1 hour. Generally, I will stop every 10 to 15 minutes and some interaction going way.
Yes, sir. Correct.
Yeah.
Any participants have any question? Okay, we can continue, sir.
Yeah. We can.
In
If
the
any
middle,
question, yeah,
if any
feel
you
free
had
to ask anyone wherever you have the question. You can ask. Feel free, no problem. So we can continue. So we are continuing with convergence technology, like feature of technology. This mixing with so like 6G plus AI plus quantum. So it's a powerful convergence. So this powerful convergence, like intelligent. So not only the AI implementing. So
Doctor?
we are. So not only implementing with the AI. So we are
Am I
implementing.
audible?
1 minute, sir. Yes, who is this? Anybody have a doubt?
Yeah. Doctor, am I audible?
Yes, please go ahead.
Thank you for your session. It was nice. Actually, I'm also looking to do some research in 6G part.
Mm-hmm.
You gave some more information, but actually, I want to know what are the driven and that the techniques which is driving the network to increase the speed as well as the capacity and the security.
You were asking techniques and.
Yeah, just we are talking about 6G, which is having terahertz speed as well as high capacity and high security, right? So how we are going to achieve? Why? Because just I was looking for the papers, journals related to 6G.
Mm-hmm.
So that time, just I got some information that will be implemented probably in 2030. Okay, so what are the techniques we are trying to implement to increase the speed from 5G to 6G in terms of terahertz, as well as what are the techniques we are trying to implement to get high security as well as capacity, more capacity?
Yeah. So for implementing security, it's a different kind, and implementing with the speed and some techniques implementing like terahertz communication is the different thing.
Yeah,
So
all
while
three are
implement.
different questions. I just
Yes, yeah, I understand. Yeah, thank you. So like while implementing with the speed called as 6G, so as comparatively 4G to 5G, how we are changing. So like 5G to 6G, terahertz communication, terahertz data, fast data transfer we are expecting. So that implementing with different hardware design, we are achieving that one. So that is under the process of the design part. So design part, we are expecting this one. So these are all the things we are expecting, like we can say. So how it is affecting, because of at the time of implementing with the 5G, AI is not correctly integrated, right? So
Okay.
6G, they are integrating with the AI also. So successfully they will integrate with the AI. Plus at the time of, definitely quantum is to be will release. Well, release
Okay.
means we can implement. The
Okay.
hardware design is to be integrating to the quantum also. So that more powerful achievement we can get that one. So that is a fast speed connection in a way. And coming to that security wise, so for security standards we can take. So how effective way 5G is to be taking. So anyway, we can implement with the better security also. Some day by day, some drawbacks will be there. So those drawbacks we can overcome and to integrate with the some additional security measures. Okay. So
Okay.
cyber attacks are, nowadays we've seen many cyber attacks are attacking. Still, they are implementing more security also. So, for example, if you consider as the spam calls also. So nowadays we can see how many spam calls we are getting in the 5G. Day by day, spam calls are increasing, fraud calls are increasing. So the messages are increasing. So these we can stop at the some security attacks, some security measures they will take care. Okay, like quantum security, or else in the synergized some smart innovation way they can take care of.
Okay. Actually, I'm asking about the techniques like any multiplexes or modulation. Anything like these can play a role to increase the speed as well as the
Sir,
capacity.
one more question is coming, sir.
Yeah, please.
Sorry for that.
Yeah, no problem.
Contribution quantum computing in 6G, sir.
Mm-hmm.
State the contribution quantum computing 6G. Somebody is asked in the chat. Is that also
Contribution of quantum.
computing in 6G?
Okay, okay.
Mm.
So contribution of quantum computing and 6G.
In 6G.
Okay, okay, okay. So basically, so we know this quantum computing. So quantum computing is, so this is rapidly faster. So how the normal machine is to be working. So that is as comparatively, so this uh, quantum computing is mainly like quantum safe security for like in quantum computing we have the quantum key distribution is there. So quantum key distribution center. So using the this QKD behavior to create with the keys. Okay. So 6G becomes with the like unbreakably secure. So how it is the secure called as using the quantum some cyber security measures they can follow. So quantum technologies provide with the additional securities like uh, we can say as like ultra fast optimization for 6G resource management. So these are all, so some optimization techniques they are following. So optimization techniques, as one of the recently, right now, one of the guy is asking like techniques. So what are all the techniques implementing with a faster speed? With the speed, also we can use with the security concern also. So for this, we can uh, uh, what we say, the some spectrum allocation also we can opt we can allocate it like 6G requests with the massive optimization. So this massive optimization is including with the spectrum allocation, beam forming, routing, user mobilities, so interference of the reduction. So these are all quantum computing solves with the optimization problems. So how it is the exponentially faster we are getting. So some techniques called as in different techniques we have. So acceleration techniques. So mainly acceleration of AI or acceleration of ML for 6G intelligent networks. So example we can say as 6G heavily depends on the AI. So how it is heavily depends on the AI called as because example we can say as traffic prediction or autonomous networking, self-healing, signal processing. So these are all we can optimization some of the better optimization techniques. And not only that one, so quantum sensors also for a high precision way. So like 6G applications. Okay. I hope I have answered.
Yes. Yes, sir. Yes, sir. Go ahead, sir. Please continue.
Yeah. Thank you. If anyone have any questions, feel free to ask. No issue in the session also. We'll answer the question and we'll move forward this one. So we are in the. So why convergence is the matters? So why convergence is the matters called as mainly first of all why combine 6G, AI and quantum. So these applications are the future. So like example we can say as holograms. So or else in autonomous robots, digital twins. So these are all the different things at the same time. For example, speed. So speed is providing with the 6G. Intelligence. AI is taking care of the intelligence. Security concern. And in the computing power. So this taking care by the quantum. So like here we just now also one of the participant was asking like the same question, I hope. So 6G plus AI plus quantum. So how it is growing called as so these three are the three different things. So integration of these things only the next future we are expecting the 6G the power like 6G with AI. So till now AI is we are using with AI, but effectively 100% AI we are not implementing. Okay, so this 6G we are expecting with the 100% AI plus quantum. So this quantum is mainly computing with the power. That is the benefit of quantum computing benefit. So this quantum is accelerating with the complex computations and strengthening with the encryption and security concern. These are all things backend maintaining with the quantum. So no single technology can meet these demands. So together means together is AI makes with the 6G networks intelligent, quantum makes with the secure concern, and 6G brings with the everything together in the real time. So these are all the why we can combine with this one. For example, we can say as like it's like a building a super city. So super city called as you need the roads first. So that road is building by the 6G. For example, smart systems. Smart systems are giving with the AI and strong security concern. So security is providing with the quantum. So this is called as convergence creates abilities that none of these technologies have the alone. So each and every technology has some superpower is there. So that we are integrating with these technologies, we are getting with the more superpower. So role of AI in 6G. So AI empowering with the 6G networks. So AI is the brain inside the 6G. So like AI handles with we can say as prediction or optimization or smart handling. So like smart mobility, or else managing with the things like core things. What are all the managing with the core things? So and detecting with the security threats. So these are all AI with handles. So AI makes with the 6G like autonomous, adaptive, predictive, self-healing. These are all AI makes. So like autonomous 6G systems, real-time network management. So these are all. So like if a tower is about with the example, let's say if a tower is overloading. So overloading called as, for example, within the one certain area, the many people are connecting to one tower. So what happened? The load is to be burdening with one tower only. So automatically the speed is to be drastically slow. For example, in the peak hours. So let's say peak hours called as evening time. Let's say evening time 7 p.m. to 10 p.m. That is the peak hours. So everyone is to be connecting to the internet nowadays, the mobile. So everyone is to be using with the nowadays 5G in the city, like in almost tier 1, tier 2 cities. Every city is covered with the 5G. So everyone is to be connecting to the one tower. So that speed is to be drastically changing, like slowing. So this AI is how it in 6G, how it is rerouting called as AI is reroutes the traffic before the crash happens. So example, let's connect with the in cloud computing. So if you connect with one data center, the heavy load is to be connecting. So immediately what happened, the data center is to be rerouting to the other data center. So our data is to be stored in not only one data center, our data is to be storing. So immediately it is rerouting with the traffic. So like AI makes 6G capable of learning and adapting. Next, AI-driven applications powered by the 6G. So it's like AI plus 6G applications. So 6G is the supercharges AI applications by giving the higher speeds, lower delay, better reliability. So these are all the 6G supercharges AI applications. So these powers are mainly like autonomous cars, autonomous vehicles, and drones, smart factories with like robot coordination, and continuous healthcare monitoring, real-time digital twins for industrial plants. So these are all we can say as different 6G applications. So let's say example like robots in a factory. Okay. So these are how robots can coordinate in the like microseconds using 6G plus AI, increasing the safety and efficiency. So this 6G allows AI to operate at all full potential. So coming to role of quantum technologies. So role of quantum technologies is mainly quantum computing, quantum communications. So quantum computing is mainly, it solves with the huge network optimization problems. Instantly it's solving with the this network optimization problems. And it is helps with the managers with millions of devices. It is accelerating data analytics. So these are managing with the quantum computing. And quantum communication is 1 minute. So quantum communication is mainly QKDs. So these quantum key distribution centers ensures unbreakable encryption. So like quantum randomness strengthens security, protects with the network, and future quantum hacking. So these things taken care by the quantum communication. So quantum technology is like adding a rocket engine. So to computing this one, okay, like security providing. Quantum safe 6G architecture. So 6G will be a quantum resilient. So resilient is mainly future quantum computers will be able to break today's encryption. So that is the power of quantum. So in 6G mainly includes with post-quantum cryptography, quantum safe algorithms, secure edge to cloud communication. So these are all will taken care by the 6G. So this protects mainly the national networks, enterprise data, critical infrastructure. So these are all taking care. So here we'll take as one example like it is like a building a bank. So that can withstand tools that haven't been invented yet. So like 6G must be secure against future quantum attacks. So next, convergence architecture overview. So in this convergence architecture is mainly 6G plus AI plus quantum integration. So this convergence architecture is includes mainly terahertz communication for the okay. So terahertz communication is mainly for extreme speed. So AI engine at edge plus cloud for intelligence. So these are all. So quantum safe layers like security layers for security and distributed computing for real-time applications or real-time processing. So everything works together like AI boosts with the performance, quantum ensures with the security, 6G provides with the connectivity. It is like a smart city. Smart city means like roads, sensors, security systems work as one. Like in simply we can say as 6G combines with the sensing, AI, and quantum security. So key benefits of convergence. So these key benefits called as mainly benefits of this integrated 6G ecosystem. So not only we had to apply with uh, fast security and intelligent connectivity. So we had to implement with the faster decisions and efficient energy usage also we can take. So like example, uh, doctors can perform with the operations. So remotely with near zero delay. So something, for example, doctor taking the surgeries or operations some hours time. So this near to zero delay and quantum encrypted safety like convergence unlocks with the next level innovation. Next, real world use cases. So these are all the some real world use cases. So like smart grids, defense systems, autonomous fleets, smart hospitals, climate modeling. So climate modeling is the most important. I think this is possible with quantum computing for simulations. Okay, smart hospitals, AI diagnostics plus quantum security, like autonomous fleets, like cars or drones moving with the together safety. Okay, so these are all some of the real world use cases like autonomous delivery drones move in the coordinated groups with 6G plus AI plus quantum with the secure communication. So next thing is the applications, challenges and research opportunities, we can say. So 6G applications and challenges. So main 6G applications is where 6G will make the biggest impact. So the biggest impact is main thing is 6G is not just a faster internet. So it powers with the new experiences and new industries that 5G simply cannot handle. So 6G is enabling with immersive holograms, real-time automation, smart environment, intelligent decision making. So it brings together like AI, sensing, edge computing, terahertz communication. So these are all. And coming to holographic and multi-sensory communication. So this is called as mainly the real-time holograms, uh, ultra realistic VR or AR, uh, tactile internet, 3D conferencing. So these are all we can take in care. Like example, 6G enables the internet of senses. Like a teacher is appears a hologram in multiple classrooms. At once, we can deliver the session in multiple classrooms, interacting in the real time. So next, coming to autonomous mobility and robotics. So this autonomous mobility is mainly need the instant decisions. So instant decisions called as mainly 6G provides with the microsecond coordination is required. So it is enabling with the self-driving vehicles moving in coordinated groups, uh, robots working, drones spams, ultra precise positioning, these are all. And coming to industry, smart cities and digital twins. So let's say smart grids. So smart grids managing by the energy autonomously, or else if we consider as public safety systems. So that detect incident instantly to detect with the precision and agriculture. So using the IoT sensors and drones, we can identify easily. And coming to healthcare. So healthcare and remote operations. So this healthcare is mainly AI-driven diagnosis and monitoring, holographic emergency care, AI-based health monitoring. And coming to real-time computing and edge intelligence. So this real-time computing called as mainly 6G blends the communication with computing. So like instant access to the cloud resources. So instant access are in the edge AI or in the terahertz based wireless communication like chip to chip communication or for the ultra fast hardware. So these are all real time computing and edge intelligence. Okay. So universal global connectivity. So okay, someone is unmuting. Okay, no problem. So universal global connectivity. So could you please mute? I'm getting the echo.
Sir, please unmute your.
Yeah. Thank you.
Thank you.
So universal global connectivity is so 6G is the first network to truly connect every layer of the planet. So like space, air, ground, and sea. So satellites, drones, and base stations and underwater networks. So these are all integrating and to truly connecting. So this enables like rural coverage, maritime communication, aviation, or else in the disaster. So these are all connecting. So some better network we are expecting, like autonomous way. And coming to 6G challenges and research oriented. So key challenges in the 6G, mainly distributed intelligence complexity, global standardization needs, security risks. So security risks mainly hyperconnected 6G environments introduced with the heightened security, or else in the uh, mainly security risks called as, more attack points will get, like more connectivity. It's like trying to build a super fast train system, but we need the tracks, engines, safety, and coordination, and all need uh, some major upgrades we require. So that is called as the uh, 6G power also brings major technical challenges is there. Okay. So major technical challenges are mainly terahertz signal attention, ultra massive MIMO, or else in the mobility management, integrated sensing and inference, future breakthroughs needed. So these are all some of the major technical challenges we can say. Coming to security risks in 6G era. So security risks are mainly quantum attacks. So future quantum computers can break today's encryption, AI-driven cyber attacks. So these deep fakes and AI-driven cyber attacks increase the complexity of threats facing the 6G security systems and privacy risks. So 6G sensing can track with the objects and people. Security AI sharing. So security AI sharing is mainly AI models shared with across devices must be protected from the tampering. So example we can say as like a malicious actor could be used with the deep fake holograms. So are spoofed with some sensor data. So these are all. So promising research areas. So research areas main thing is the terahertz antennas and propagation models, and RIS, reconfigurable intelligent surfaces. Uh, so RIS optimization is the one, like designing the smart surfaces for beam reflection. So these are all. And decentralized AI and security, and 6G digital twins, like virtual replicas of networks. Okay. So 6G research is like exploring a new scientific continent, like full of open problems, like can say as massive scope for the R&D and innovation and publications. So these are all. And next, academic and industry opportunities. So with the research publications, industry collaborations, student project focus. So these are all you already these things. I hope you are following with the same thing every organization and from the academic perspective. So coming to 6G, new era of intelligent communication. So this 6G represents in the next the 20 years of wireless innovation. So it brings together with the terahertz communication. So terahertz communication is the mainly extreme speed and AI native intelligence, like smart networks, quantum security, like future-proof protection. So India has a huge opportunity with the research, startups, and the academic contributions, industry collaborations. Okay, so these are all just to explore with the future ready domain. So 6G is not just the it's like next network. It is the platform for the next technological revolution. Okay, so just 6G will influence with the education, industry, society, innovation for the next decades. So we are expecting the same thing. So this is the content. Okay. If we have any questions, I hope time 7:57. Okay. Yeah. So any questions you have, feel free to ask.
Dear participants, anybody have any questions related with today's topic? You can ask. Nobody have? Okay. Thank you very much, sir.
Yeah, thank you. Thank
Dr.
you,
Sir.
Vandal.
On behalf of our institution and all participants, it is my privilege to extend a sincere vote of thanks to the Dr. Vijay Nalamuthu for delivering such insightful and enriched session during this faculty development program, sir. Sir, your deep knowledge and clarity of explanation and the practical perspective you shared have truly abundant our understanding. The way you connected concept with real-time application made the session not only informative but also highly engaging, sir. We are grateful for the time and effort you dedicated to preparing this session and addressing our queries with such patience and enthusiasm. Your contribution has undoubtedly added a great value to this FDP, and we look forward to many more opportunities to learn from you in the future, sir. Thank you very much, sir. Once again from my side.
Thank you.
Sir.
Thank you, one and all.
Thank you very much.
So one question he's asking Lakshmi Chaudhary. So which tools are used for research purpose in quantum computing? So for quantum computing, IBM tool is there like Qiskit. So that is the basic thing for learning purpose also. Qiskit tool is very hands-on, like not only the theory purpose. If you know the basic Python something, Qiskit tool is there, open source SDK. You can explore that one. So other tools also, many tools is there like Google Search, Amazon Bracket, and like Microsoft product QDK. QDK is there, and some TensorFlow Quantum also there. Not much that one. I'm not aware, but this Qiskit tool is very useful for basic learning things for quantum. Okay.
Any
Nice.
other have any questions?
Yeah.
Any query?
Thank you.
Thank you very much, sir.
Yeah. Thank you all. Bye.
Bye, sir. Thank you very much. We'll meet again.
Yeah. Thank you. I'm leaving, sir.
Yes, sir. Thank you very much,
Yeah.
sir.
Thank
You can leave,
Bye.
sir.
Yeah.
The attendee is going to share at the end of this session. The session going to end at 9:30 p.m. And next, what we call our resource persons, Dr. Kiran Gaikwad, sir. Kiran Gaikwad, sir, is there?
Yes, sir. Good evening. Am I audible?
Yes, sir. Yes, sir. Good evening, sir. Good evening, sir.
Okay. Thank you,
sir.
Dr.
Welcome to the FDP, sir, Faculty Development Program, organizing from the Sandeep Institute of Technology Research Center. I'm going to introduce the Kiran Gaikwad sir to the all participants. Kiran Gaikwad sir is accomplished academic and DevOps professionals with overall 18 years of experience in teaching research in the industry. He hold a PhD in computer science with strong expertise in DevOps, automation and cloud technologies and machine learning. He has published multiple SCI index research papers as well as journals, contributed to major academic events, and develop a automation tools to enhance the academic and technical process. Once again, thank you for joining us, sir. Over to you, sir. Kiran Gaikwad, sir.
Thank you, Dr. Mohammed, sir. Okay. Good evening, all. Am I audible?
Yes, sir. Yes, sir. You are audible.
Okay. I will be sharing my screen.
Yes, sir, you are audible.
Just let me know whether it is visible and my voice is clear.
Yes, sir. Your screen is visible.
Okay. Fine. So I think this is the second session of this FDP.
Obviously, sir.
So it is a AI for next generation wireless networks. I hope that you have the brief introduction now about the next generation networks in the previous session. So I will be covering that also in this session. The introduction to the next generation wireless networks, the background of the networks, the revolution of the that networks, wireless networks from 1G to the 6G. So that I will be covering here in this entire session, and whatever the knowledge I am having, so that I will be discussing and exploring with you all. So I hope that with this session we will be going to get a somewhat understanding on the wireless networks of the next generation and the use of the AI for these wireless networks. So moving ahead, so the session objectives which I proposed to understand the critical role of artificial intelligence in next generation wireless communication system. So as currently we are having the 5G, which is currently used in the world, and we'll be moving ahead with the 6G. So that is the future generation networks, which is to be planned and it is to be implemented. So we'll be focusing on that as well as the background behind the historical, or we can say that the past generation networks which are there. So understanding on that and the flaws which are present over there, or the drawbacks, or the whatever the understanding we are having with that, can we cope up with the 6G network? So that we can going to have in this discussion. So the second objective is to explore the core AI techniques applied in the autonomous networks. So the purpose of the AI is to maximum to get the predictive analysis from the networks. So whatever the data is flowing through the network, so we are going to have the analysis, and based upon that analysis we are going to predict what kind of the measures we can going to consider to avoid the different incidences which will be going to be present over there. So that is the second objective we will be having, and to discuss the research challenges and the opportunities for the academia and the industry. So that is the third objective which I kept for this session. So a little bit understanding of the networks. I hope I know that the most of the people are from the faculty or the academia, so they might be having the understanding on that. Still, I will be going to covering the background of the networks and the wireless networks which is to be used. So as we know that the networking is the art of connecting devices and the systems and the people. So whatever the devices are present over there, now it is not limited only to the laptops or the desktops or the servers. So now we are having the different expanding IoT devices, Either it uses cameras, door locks, doorbells, refrigerators. So all these are the different IoT devices which is going to be used to automate the different applications in daily usage. So those are also going to be connected together or to at certain level to get the information and to process the data. So uh, the networking has extended from the local area networks to the wide area networks that we have seen earlier. But now from the Wi-Fi to the internet networking is also going to be providing the way of the communication for the world. So that is how the networking has changed the way of communicating with the people or the devices. So the computer network, which is used for the communication, is a collection of the different computing devices, laptops, desktop servers, smartphones, tablets, as well as the different IoT devices. So that is how the networking concept is extended. Now, when we talk about the wireless networks, so whatever the networking we are having, either it is wired or the wireless. So in the wireless networks, again, we can have these kind of the computing devices which are connecting together to share the information or to provide the way of the communication. So as the devices are extending or the expanding, so the way of the communication for these different devices is expected to be present over there. This is how the networking revolution is happened. So if you see that we are having the 1G, which was in 80s, we witnessed. Those are the 80 kids. Those witnessed first G or the 1G. Then we move ahead with the that 2G, and then 3G, 4G, 5G, 6G, likewise. So every generation of the wireless technology provides more durable speed and adds extra functionality to the mobile subscribers. So whatever the need is generated during those eras, so that has to be that is satisfied by those each generation, and that is going to provide the benefit to the world. So first G allowed the large size portable cell phones, and it has used the analog voice to communicate with the people. So only the uh, the purpose of that first generation was to provide the communication between the people, and the use of the we can say that the cell phones was uh, intended only for the communication with the people. The different algorithms, or we can say that the techniques which are used which were used in the first generation, that is advanced mobile phone service and the Nordic mobile telephony. So that has used for providing the end user communication in the first generation. The second generation, where the analog voice is now uh, transformed into the digital voice, and then the one additional feature along with the communication is provided in the second generation, that is a messaging system. So we can have the text messaging with the 2G and the devices which will present over there, and that is how the transformation is done. So from the first G to the second G, which is having only the analog communication, that has transformed in the digital communication, and in addition to that messaging system is provided. Whereas if we think about the 3G, that is the third generation, where the internet service is provided to the user, and with that internet services, so whatever the information has to be retrieved at a limited or the restricted way, so that was possible with the third generation. So the rate, we can say that the internet rate of the data transmission was the 2 Mbps, which was defined for the third generation, and that would be used for the connecting the different people through that 3G that communication era. So next was the 4G, where the high speed data rate which is defined, or which was expected, along with that internet connectivity or the mobile data which was provided with the 3G. So as the information which we were expecting, so it was, we can say that as compared to the third generation, which was huge. So the data rate which is expected, so that should be the higher, and that's why the 4G focused on that. And with that, it has provided the high-speed data rate and used that to provide the quality of the service to the user. With that quality of the service and the quality of the experience, 4G has enhanced the quality of the communication and the data access. Now, from the fourth generation, where we define that the traditional mobiles and the other handheld devices which are using the frequency spectrum between the 3 to 6 gigahertz. So now, as more devices are connected together with the internet, so the 4G network is starting to get more crowded, and that due to that the services which is to be used by the users are get stuck, and the whatever the maximum frequency spectrum which was provided, so that was get utilized over there. So with the limitation of that, it is expected that the new generation or the new way of the communication is to be used as the number of the devices are get to be connected. With that connectivity, the slower service which was facing in that generation, and the processing capability for the data on the smartphone was very low, and that's why it was expected to have another way of communicating with the different devices which were increasing enormously in the world. So nowadays users are directed towards the 5G technology, the next generation wireless technology, where the telecom industries are incited to develop the 5G technology commercially. But as expected, 5G is going to deal with the 1000 times more traffic compared to the today's that cellular network, and it is going to have the more stable connectivity than 4G, which is the we can say that the good or the better uh, feature which we'll be getting with the 5G. So 5G is providing the foundation for the extended reality. Those are the different features or the techniques which will be going to be used, as along with the text, which was the 2G generation facility provided for the communication. So as the data, where the multiple data is going to be present, so either it is audio data or the visual data. So that's why the different kinds of the applications, whether it is a extended reality or if it is a industry automation, 4.0 automation, or the different internet of the things or the IoT devices are get to be connected with this to utilize this feature. So 5G include the different kinds of the technologies, such as that is wave, which is nothing but the microsecond or the millisecond wave, small cell towers, which is another feature which is used in the 5G, beamforming, that is another feature available, massive multiple input, multiple output, that is massive MIMO, and the full duplexes. So these are the 5 different technologies which were present in the 5G, and those are going to be provide the better kind of the quality to the user to access the data, share the information, or the way of communicating with the different applications or the people. So that was the feature which is present in the 5G, which was provided by these different technologies. But as we know that the coverage which we will be getting by the 5G, and as you see the enormous increase in the devices which is going to access the internet is increasing rapidly, and that's why the 5G which is available, which is we can see the coverage of the 5G is not that much, and the different compatible devices which are present over there with the 5G. So that is also the one of the problem which is present with the 5G, and that's why considering these different drawbacks, the researchers have decided to go for the new generation of the that era, that is the 6G technology. Now, as with the 5G, the data which is to be shared, So it was with the terrestrial structure, or we can say that the ground to ground data which will be present over there. But now with the 6G technology, the way of connecting the different type of the we can say that either it is a air communication or the satellite communication which is present, or the ground communication or underwater communication is present over there. So all these different types of the environments are to be used, and with that use we will be going to connect anywhere with the 6G technology. So that is the purpose which is kept in mind for developing the 6G technology. So for using that 6G technology, ultra reliable low latency communication is one of the feature which is expected to be present in the 6G technology. Has the high networks dependability and with the low packet communication delay. So that is what the feature which we are expecting in the 6G technology, which is provided by the ultra reliable low latency communication. With these two characteristics, 6G provides the data delivery in a matter of milliseconds or the microseconds with excellent trustworthiness. That is what we are expecting with the 6G technology. And now this 6G technology, which is to be considered as a future and which is to be planned to be introduced by 2030. So that's why it is a future generation technology, or the next generation technology, a wireless technology which is considered. I hope there is no any low audio from my side.
Everything is perfect, sir.
Okay, fine. Thank you so much. So we'll be moving ahead. Now, the next generation networks. So as I stated that not only the communication which is going to happen on the ground, so we'll be going to consider the communication in the air, that is through the satellites which is going to be present. So the satellite communication, the ground communication, and the sea water communication, or the under the water, under the ground, we can say that the communication. So that three different environments are going to be used for considering this 6G technology, and where these three environments are going to be communicate, or whatever the devices are present over there, applications are running in these three different environment can be communicated with the 6G technology. So that is what the purpose which is defined, and these technologies are known as the next generation networks. And that is the upcoming evolution, as I stated, that is by 2030, that is going to be planned for the that is in process and get developed. We can say that the complete package will be available by 2030, that is aimed. So these networks aim to deliver faster data speeds, reduce latency which we are facing in the 5G, and the enhanced connectivity. For when we are going to define that any network, so data connectivity and the internet, so these are the pillars for communication purpose. So that's why the enhanced connectivity, whereas when we are going to have the data communication or the data retrieval or the sharing of the information, the latency which we are expecting. So for example, if we are playing the video, and if that video is get delayed, so it will not going to give the good impact on that particular application. So that's why the latency is going to be reduced. Minimum latency will be available. So that's why the ultra latency is the major component is going to be considered for the 6G technology. So 6G networks going to have the wide range of the that is wide range of the environment is going to be covered. That is either it is a terrestrial or the non-terrestrial networks, as well as it is a combination of the both. So terrestrial in the sense that the ground, as I said that if you will see the next slide, in that next slide, so we'll be having the define the ground-to-ground communication, or the we can say that the which is present on the ground, that kind of the communication will be present. Similarly, under the water, the communication, different applications, different devices, if those are available, so we'll be going to have that kind of the communication and the facility which is to be provided by the 6G networks. So this is what we are expecting by the that 6G networks. Now the why we are moving ahead with the 6G. So that is what the so emerging technology, we can say that. But why it is emerging technology? The usage of the internet users is increasing continuously. So if you see that the count which is present for the internet users in the world, so it is a 5.3 billion, and which is now again it is increasing. Okay, so that's why it should uh, accommodate all these internet users, and though the users are increasing, still the way of the data access should be free to the users. Free in the sense that whatever the access it is available, though the number of the users are increasing, there should not be any kind of the delay or the bandwidth which will be present over there, so that utilization of the bandwidth is going to be proper or efficient, we can say, and that should be available. So if you see that there is a uh, uh, high number of the internet users are present in the world, and now as the users are increasing over there, so whatever the security measures are going to be considered, so that security measures are to be uh, imposed on that particular technology. So that's why, as nowadays we are having the AI, that is a emerging again, that is another domain which is present. So why we cannot use that AI for the automation of this kind of the problems or the issues which we are facing? So whether there is any way those AI techniques which are present over there that can be used for defining these applications and designing this kind of the technology. So that's why this complexity of this scaling is actually driving towards the that 6G technology for the AI. So now, along with the normal traffic which we'll be having, so we'll be having again the AI traffic if we want to use AI with the 6G technology. So along with the data, we can say the voice or the that media data. So that AI traffic is the another parameter or the another we can say that the uh, parameter which is going to be present with the 6G technology. Now, if you see that in this graph, so this is showing the digital connectivity or the digital usage of the India. So that is taken from that digital uh, uh, portal where the data is available. So uh, 112 crore that mobile connections are currently, that means at the end of the 2024, that was measured, those many number of the mobile connections were present. Then the internet users which were present, so those internet users were 75.15 crore. Those many internet users were present at the end of the 2024. And the social media users, those increased, that is up to 46.20. So that kind of the rise is present when the data is floating through the entire network. So due to this rise, whatever the capacity, whatever the bandwidth, or whatever the way of that 5G technology which is developed, so that is not sufficient. So that's why the 6G technology has to be considered for providing the better kind of the service to the users. So this statistics provides the importance of developing the 6G technology. Now, the limitations of the traditional communication. As I stated that there are five different technologies which are used in the that 5G era. So that 5G era, which is going to contain, that is millimeter or the microsecond wave, that is one of the technology which is present over there. So it is a type of the 5G network that uses very high frequency bands, above 24 gigahertz to deliver ultra fast speeds and low latency, but with limited range. But still, though it is providing the high frequency band over there, but there is a drawback of this web. So it cannot travel through the obstacles such as buildings, trees, and the walls. And that's why this technology or this way of the communication is not reaching to the users. And that's why there is a, we can say that the delay or the interruption which will be available, will be present in the communication. And they tend to be absorbed by the trees, these waves, in the bad weather condition like rain, and are affected by the different environmental or the weather conditions, and that's why it will be get weakened, and that's why there is a delay in the communication, or we can say that the retrieving the data. So that's why these traditional communication channels, that is wave, which is present in the 5G, is also not sufficient to provide the way of which we are expecting in the 6G technology. Next is the small cell towers. So these small cell towers is a low powered compact cellular base stations. So it is generally size of pizza box. These small cell towers are designed to boost the network capacity and coverage in the localized areas. So like the stadium which we are considering. So in the small regions where to get the power boosted, so these small cell towers are get utilized. So generally it is fixed on the existing infrastructures. Those existing infrastructures, we can say that the poles or the towers where that can be kept, and they are utilized with that capacity. But if we think about the small cell towers, so they are dissipating the power, that is power consumption, which is the major flaw for the small cell towers. And as we'll be going to increase the number of the small cell towers, so that's why the power consumptions will be more, and that's why with that this small cell towers, the if the density of the small cell towers is increased, so there will be the more power consumption, and that's why that would be making the major drawbacks for or set higher cost of the implementation for the that 5G technology. Now next, if we will be moving ahead with the next technology which is present, that is massive multiple input and the multiple output, that is MIMO. So it is a way of wireless communication where large number of the antennas that is present at the base station, and the purpose of this collection of the antennas is to improve significantly network capacity, data throughput, and the reliability. But as we are going to have the large number of the MIMO, these different devices or the way of the communication which we are using, so this, if it is going to be present, so they will be going to have the interference, and due to that interference, that will be reducing the power of the communication, or we can say that we can have the weakened signals which will be reaching to the users. So it will be requiring the more signal processing algorithms to improve the quality of this massive MIMO technology. So that's why that is a another drawbacks or the setback for the 5G. Now with the 5G, most existing technologies are not called. So we are not going to use the existing technologies we have with this 5G, as the requirement is different. So that's why these different uh, new technologies are get used. So we are not utilizing the existing technologies. So that's why there is a redefined structure will be present, and that's why the existing devices which are present, so that are not competent with this 5G technology. That is another setback or the drawback which we can say for the 5G technology or the traditional communication. Similarly, 5G is not that much mature, as we are experiencing that scenario, that is weekend signals or not reachability to the uh, that rural areas. So that's why this 5G is not that much mature with the security aspect, similarly the privacy and the authentication. So these are the three different measures which are going to be considered to define the maturity of this 5G, and that's why this 5G technology is said to be a not that much mature in the sense that that much trained, that much how the visibility to the user. So that's why this is another drawback which we will find in the traditional communication. Now similarly, if we'll be moving for the automation, that is one of the way which we'll be having for the industrial transportation and the vehicular communication, require a ubiquitous network which expects the ultra broadband cellular networks. Similarly, the high uplink as well as the downlink. So that is also needed when we are expecting the communication or the automation for the industry or any transportation mechanism which is to be implemented for the vehicle communication. So this is going to be provide the we can say that the limitations for those different applications which we are expecting in the future. Similarly, the intelligent devices, intelligent vehicles, or the drones or the other vehicles used in the military operations require the high data rate. Similarly, the coverage should be extended, so it should reach to the, we can say that the different areas or the parts where the military operations are going to be taking place. So that is going to be covered by these different technologies, that technology which is not possible with the 5G, and that's why it is expected to have that 6G technology. Then similarly, as we are expecting to in the future, the satellite communication is to be happen, then the plane communication, bullet trains which are going to be present in the future, then similarly underwater communications require the negligible delay, and that's why this 5G are not going to provide that much kind of the capability for developing the applications or the communications in these different domains. So due to these uh, limitations, the era of the 6G is to be expected. I hope it's fine. Hello, am I audible?
Yes, sir. Yes, sir.
Yes,
You're
yes,
audible.
yes, sir. Yes, sir. Yes, sir.
Okay, okay, fine. Now, what we are required for the 6G wireless technology, with the drawbacks which we have seen, with that, the different parameters which are expecting for the wireless technology, which is 6G wireless technology. So that is defined with this diagrammatical view. So we are expecting the high user data rate, because as the users are increasing enormously, so though the users are increasing, the data division will be going to happen over there, or the bandwidth division is going to be happen, but that should not affect on the usage of that data to individual users. So that is what we are expecting, the extreme high user data rate. Then similarly, extreme high spectrum efficiency. So the spectrum which is used for the wireless communication, so that is a limited, that is a defined. So that spectrum capacity, but we are not actually utilizing it at the maximum extent. So that's why it is expected that the capacity of that spectrum is effectively utilized, and with that we are going to have the capability of the 6G technology which is going to be enhanced and expected with this spectrum efficiency or the high spectrum efficiency. Then extreme high mobility. So though we are moving at any environment, either it is on ground, in air, or under the water, so the that mobility should not affect on the usage of that particular internet or the data connectivity or any kind of the communication which is going to be happen over there. So that's why we are expecting the extreme high mobility. Though the extreme high mobility is present, still it is not going to affect on the usage of the that data and the communication. Then
Sir, please just uh, switch on your audio, sir, please. Hello. Uh, Kiran, sir.
Sorry.
Okay.
Huh. Actually, where I was, so I don't know exactly when I get
You're
this.
explaining this diagram, sir.
Yeah. So I started with the high user data rate. So I was there with you with that point.
Yes, sir.
Okay. So I'll be moving ahead with that high user data rate, high spectrum efficiency. So in the high spectrum efficiency, utilization of that spectrum, which is going to be utilized for the data communication or the communication, wireless communication. So that is expected. Extreme high mobility, that is what I stated, that when we'll be at any environment, either it is in the air or on the ground or under the water, so that should not change or the affect on the usage of that particular data or the communication or the internet access. Extreme low energy usage, so as I stated that when we'll be using the small cell towers, those small cell towers are dissipating actually the powers, and that's why they are more power consuming devices, and that's why they are using the energy usage will be increased when that kind of the technology is going to be used. So that's why we are expecting that whatever the technology we are going to prefer in the 6G, so that should have the low energy usage. Whatever the different devices or the components are going to be present, so it should have the low energy usage over there. Extreme low latency, so that latency of communication or the data retrieval or the data access should be low. That is minimum that we are expecting. So ultra level of the latency we are expecting over there, so that's why it would be the negligible latency, and that is what expected in the 6G technology. Then the extreme high connection density, so whether wherever we are, either it is a rural area or the urban area, so based upon that, either it is a dense area or there is no any rare population is present over there, still it is not going to affect on the usage of that particular technology, what we are considering as a communication or the data. So extreme high connection density will be there. Extreme high network efficiency, network should not be down at any time. So if it is a down, so that should not be easily understood, so that is ultra level of the downtime should be present with that network. So that is what we are having, the extreme high network efficiency. Extreme high reliability, whatever the data we are sending, whatever the communication is going to be happen, so that communication should be reliable in the sense that whatever the packets are going to be transferred, so those packets are not going to lost at any intermediaries stages which will be present in the communication path. Extreme high area traffic capacity, so if the traffic is get increased or at certain peak level, if the traffic is increasing, still it should have that kind of the capacity, or it should increase its capacity so that it should not affect on the that communication which is going to be happen or the data transfer is going to be happen over there. And the next is the extreme high peak data rate, so that is the relevant with that high traffic capacity. So peak data rate in the sense that at certain times when we are saying that there is a sale in the Amazon, if we are accessing the Amazon website, for that Amazon website for festival season or at certain periodic times, we'll be having a sales over there, and as sales is there, so during that period the traffic is going to be increased, and that's why that traffic increase should not affect on the way of the data or the communication which is going to be happen with the user. So that kind of the we can say that the handling we are expecting from this 6G wireless technology. So this is how we are expecting the 6G wireless technology should be present in the future. Now, next is the 6G enabled technologies which is to be used over there. I hope you are with me, all of you.
Yes, sir.
Okay, fine. Now the 6G enabled technologies, what we are expecting, as we have seen the requirements, and based upon that, the technologies which is to be present with the 6G that are defined. So we are expecting, as the automation is present currently, and the artificial intelligence is one of the scope which is present for dealing with the tech networking. So that's why we'll be having the AI enabled intelligent computation and the communications. That is what the one way of considering this 6G technology. So there are various machine learning and the deep learning models have been introduced for intelligent decision making, similarly for the resource provisioning at the local edge devices. So edge devices are nothing but that we'll be going to cover with the edge computing, which will be present in the coming slides. So we are expecting that the edge devices which is to be present over there, and the control the data flow with the efficient intrusion detection mechanism. That is what we are expecting with the 6G enabled technology. For that purpose, we are using the AI enabled technologies which are helpful, as the data flowing through that particular network. So it will be a large amount of the data. So if we extract that particular data or the meaningful data, so from that meaningful information, we can have a certain kind of the decision or the sensing that particular data. With that sense, we will be going to have a certain mechanism that is going to take the decision, and that will be useful when we are dealing with the applications which are going to be used with this 6G enabled technology. Whenever we are transmitting the critical data through the local edge devices, the 6G enabled network should have that kind of the capacity to provide the security, as the edge computing is not in the area of the networking, so it would be the beyond that networking. So that's why the security measures which will be going to be considered with the edge computing, so we are going to consider that with the AI enabled technology which will be used for the this 6G technologies. Next, we'll be having the terahertz communication. One of the challenging tasks of the time critical application, such as patient monitoring in the healthcare, traffic management, is to transmit the data to the local computing devices with advanced communication technology for minimizing the latency and the providing the faster response. The terahertz property of the 6G technology, which is ranging from the 100 gigahertz to the 10 terahertz. So this brings the revolutionary network potential with the high data rate. So we are expecting the data rate in this terahertz communication is greater than or equal to the 1 terabits per second. And that kind of the high data rate, it will have the high frequency connectivity with the real-time IoT devices, which we will be going to deal with the real-time data with the IoT devices. So that would be get benefited with this high frequency connectivity which is provided with the terahertz communication. So with the terahertz communication, it is having the molecular absorption, and due to that, minimum propagation loss will be there, high penetration loss will be there, and those properties of the terahertz communication in the 6G technology helps to transmit the sensed data to the nearby edge devices with the minimum latency and the energy consumption. So this is how this terahertz communication, which is one of the feature which we are expecting in the 6G enabled technology, so that is going to provide the ultra latency delay for the communication purpose. Next is big data analytics and the network dynamicity. So this is another way of dealing with the communication which is going to be happen with the 6G enabled. As there is a large amount of the data is going to be present, so analysis can be done with that data, and with that analysis, certain decisions or the we can utilize that data for the predictive analysis as well as for the decision making. So certain devices, IoT devices such as wireless speaker, smartphones, audio assistant, and the smart lock are connected with these networks. Most of the data intensive applications generate an enormous amount of big data for the further processing at the local edge devices. But we are going to decide, as the data will be at large amounts, so we'll be going to collect the data from the edges. So what kind of the data is to be collected from the edge devices, that has to be that would be going to be decided with this uh, feature which will be going to have in this 6G technology. 6G technology has introduced 4 different types of the network analytics, that is descriptive analysis, perspective analysis, and predictive analysis. So these analysis ways are going to actually process the data, and based upon that we can have a decision making can be done, and what kind of the data, what kind of the patterns are there, what kind of the data is flowing through that particular channel, that is going to be identified or analyzed, and based upon that the security measures can be considered over there. So this is the way that is we are expecting with this 6G through the big data analysis. Next is the blockchain enabled communication. Uh, the blockchain is a peer-to-peer distributed technology which is going to have the trust establishment, interpretation, decentralization, security, and can reduce the underpinning infrastructure and the maintenance cost. And that is what the best benefit which we will be going to have through the blockchain enabled communication. So blockchain technology is suitable for real time IoT applications in the 6G enabled edge network. The 6G enabled networks, which is containing the blockchain, can transmit the data efficiently to the distributed edge devices, and further it will evaluating that particular channel for minimum delay and the higher reliability. So that kind of the mechanism we are expecting with the 6G enabled technologies through the blockchain. So this is a blockchain enabled communication is a way of defining the 6G technologies. Next is wireless power transfer. Now as we seen that in the smart cell towers, so it is having the power consumption, and that's why that would be the major setback for the 5G. So here with the 6G enabled technology we are expecting that the wireless power transfer, so that wireless transfer will be generated through the nature, we can say that through the power harvesting. So either that power harvesting is going to have the solar energy harvesting, or it is a wind energy harvesting. So these are the different ways by which we are generating that particular energy or the powers, and that can be transferred to these different channel of the communication medias. That is what we are expecting by the wireless power transfer. So these are the different 6G enabled technologies which are used for the communication, and that is get the expected outcomes which we are expecting from the 6G. So that would be get satisfied with these different ways of the technologies. Now from this networking technology, we'll be moving ahead with the AI, that is rise of AI, which can be used with this 6G technology or this next generation technology. So AI is introduced the with the major application which was introduced in the world, and that is in 1997, which was IBM's Deep Blue. That was a computer which is competed with the Gary Kasparov for chess playing, and uh, through that competition, actually, that IBM Deep Blue is actually won that particular competition, and that machine has defeated that Gary Kasparov. So it has actually uh, get, we can say that the gain the weightage of AI or whatever the research was carried out earlier, so that get fruitful with this competition win. And now world is going to recognize that AI can be used for the societal, or we can say that the different applications which can be utilized for the uh, making the human more comfortable, or how we can utilize that AI mechanism to make the human comfortable. So that way of thinking is increased, and uh, now we can see the different AI applications in daily life are present over there. So IBM Watson is one of the another example which was present over there. That is uh, one of the game show which was present in the US. So in that IBM Watson, which was trained by the different data sets, and through that data sets, it is going to be asked, that machine has get asked the different questions. So that that show which was present over there in the US, and that machine has answered all the questions which is asked in that particular game show. And that's why that is another the usage of the AI application which noticed by the world. The AlphaFold, that is Google DeepMind's one of the AI application, which is used to identify the protein structure, Alzheimer's protein structure, or any disease. Specifically, it is used for the identifying the protein structure, and through that we are going to understand what kind of the disease and at which level it is present over there. So that kind of the healthcare advancement with this AI technology has actually given the way to think the people how the AI is going to be used over there. So now with this aspect, if we utilize that AI, as there are a lot of things are present in the networking which cannot be handled by the human being, because as the number of the users are increasing, if any kind of the network get down or any kind of the network components goes down, so it would be not get identified easily or not feasible to actually uh, find out in which network communication channel or in the networking area that particular component is get failed. So that's why we are expecting that network autonomy should be present over there, and that network autonomy can be provided through the AI. So what we are expecting that most of the time when the network is get down, so the configuration which is expected, that is we can say that the prerequisites or the configuration, basic configuration which is to be done. So the manual intervention, if it comes over there, so it will be taking the time, and as the manual configuration is going to be happen over there, so the downtime is going to be increased. So instead of that, if in advance, if we are going to identify that a certain traffic is going to be increased at the certain area, so we are going to either increasing the bandwidth over there, or we are going to reroute the traffic which is present over there. So that kind of the mechanism is going to avoid the downtime which is present in the network. So that is what we are having, the network autonomy. And in the network autonomy, we are expecting that the self configuration, self optimization of that particular network structure, or the networking components which are present over there, self healing. So if one of the component is get particular failed, so either it has to reconfigure that and make it operable, or it has to identify another route which can be used for traffic diversion. So that kind of the mechanism we are expecting, as there is a huge usage of the uh, devices, different kinds of the devices, different kinds of the components, different kinds of the users are going to be connected or associated with the network. So if the manual intervention comes over there, so it will be increasing the downtime of the networking, and that's why it is going to affect on the usage of the that data or the communication which is going to be happen with the user. So that's why this network autonomy is expecting that the self configuration, self optimization, self healing should be present over there, and that can be done with the AI. So what are the uh, different ways are present for the artificial intelligence? So using those artificial intelligence ways, can we automate the networking which we are expecting over there? So that is possible with the AI. Now, uh, the actual usage which is already ongoing with this AI. So Jio is using AI for network optimization. The video link is provided. We'll be going to see one of the video which is going to give you the idea about that particular uh, AI networking which is present. Similarly, AT&T is using the AI for the predictive maintenance. Cisco DNA Center Machine Learning, which is going to be used. Cisco is using the DNA Center with the machine learning. So that is the different examples which are uh, having the adoption of the AI, and by the adoption of the AI, how it is improving actually that particular uh, mechanism, that is structure which is present in the networking. So that is defined with this actual usage of these uh, uh, different companies, either it is Geo or the AT&T or the Cisco. So I hope
Sir, it is no audio. We are not getting any sound. Kiran sir. Hello.
Yes, sir.
Sir, there is no audible.
Hello, am I audible?
You are audible, but the video which you are showing, it is not audible, sir.
Am I audible? It's not audible.
Yes, it is not audible.
Okay. Okay, I will be sharing that link so that you can go through that particular video and you can understand the usage of that particular uh, AI which is used in that Cisco for optimization of the network through the SDN, software defined networking. That is one of the feature which is present to decouple the hardware and the software. So I will be going to share that. You can go through that. In the chat box, I will be sharing that. Hope I am audible.
Yes. Yes, sir. Yes, sir. Please share it.
Yeah. So you can go through that and have a look on the usage of that particular AI which is utilized over there. So we'll be moving ahead. Now we'll be going to see the AI taxonomy which is applicable for the wireless system. It is applicable for every entire applications which are to be designed. So artificial intelligence, as we know that it is a way of creating machines which are intelligent one, and those machines are going to use the automation. Those machines are going to use the machine learning. It is going to use the generative AI over there. So neural network. So the different ways are present over there by which we are going to create intelligent system. So that is what the artificial intelligence is defining. Whereas if we'll be moving ahead with the uh, machine learning, which is a subset of that artificial intelligence. So we'll be going to use the different mechanisms or different techniques to make that machine to understand it. So either it is a supervised learning or the unsupervised learning. So through that we are going to define the way of how the machines are going to be learn or get trained, and with that training we can make the use of those different understanding for different applications of the perspective, either it is a predictive analysis or whether it is a decision making. So that can be done with this supervised learning or the unsupervised learning. So these are the different examples which you will be going to define. As simple examples I have put it here. So supervised learning in which AI models are trained on the data, and that data is we can say that the classified data, the labeled data. So here you can see the simple examples. We will be having the different animals which are defined, and the different animals with the different features which is going to be present over there. We will be providing the feature extraction, and through that the training to the that particular model is given, and based upon that, if any kind of the test data comes over there, we are going to identify that particular pattern, and that is what the labeled classification is the way of using the supervised learning over there. Next is unsupervised learning, where we are not going to use any kind of the labeled classification or the labeled data. Unlabeled data will be present over there. We'll be going to find out the features of every class which is present over there, and based upon those features which are finding the more proximity or the more possibility, so we are going to correct it. We are going to match it, and we are going to identify that particular class over there. So these two different ways of to train a particular model, and based upon this training actually we are going to get the understanding, or we can have the decision making over there. Reinforcement learning is the another way by which we are going to make the machines to understand the train. But the way of reinforcement learning is that initially we will be going to train the machines, and if it is finding a particular uh, answer or the output which is not the correct one, so we will be going to punish it. And if it is not having any kind of the or it is having the accurate measures, so it is get rewarded. So it is a trial based or the trial and error method mechanism which will be going to present, and based upon that learning we will be going to actually enhance that training model over there. So this is a reinforcement learning algorithm which is available present in the AI. That is a type, we can say that, in the artificial intelligence. Then the deep learning, which is mainly focused for the wireless networking, which is a part of the machine learning. So deep learning works by using artificial neural networks to learn from the data. Neural networks are actually made up of different kinds of the layers which are interconnected together. So those interconnected nodes, which is known as the neurons. So each node is responsible for the learning a specific feature of the data. There are different applications generally applicable for the deep learning. So we can have the simple example, that is in the image recognition network. The first layer of the nodes generally going to learn to identify the edges of that particular object or the image, and second layer might be going to learn the shape of, we can have the, with the help of the edges, the particular structure, that shape is get identified, and in the third or the next layers we'll be going to identify the object. So it is the layer wise processing of that data, and based upon that we'll be getting the refinement of the object identification or the recognition. So that is how the deep learning is going to work. So it is a layered structure where we'll be going to provide the input, and through that we'll be having the hidden layers which is get processed, and the output is going to be generated over there. So deep learning is the way by which we are going to make the machines trained, and we are going to understand those machines which are trained can be used for the making the decisions, or the decision making systems can be defined. Now, when we say that the deep learning and the machine learning, those are the part of the artificial intelligence. Machine learning is a broader way, whereas this deep learning is the part of the, we can say that, layered refinement which will be going to be present over there. So that would be possible, and we'll be getting the refinement result with the deep learning as we are processing through the layers. So we'll be getting the better understanding on the data by the deep learning. Machine learning and the deep learnings are both applicable for the tasks which can be classification of the data, pattern recognition. So whatever the network data is present over there, so that network data, so we are going to analyze it, and based upon that analysis, what kind of the patterns are present over there, so that can be understood with the help of this technique. Machine learning actually uses the human intervention to correct the different kinds of the outputs which are generated, whereas in the deep learning actually the minimal human intervention is present over there. So that is the basic difference we will be having for the deep learning and the machine learning. So these are the different algorithms or the techniques which is present in the AI, which can be used for the network optimization, network configuration, for the network healing. So the different the basic mechanisms which we are expecting in the network autonomy, so that can be done with the help of these different AI techniques which are available over there. So this is the example which is demonstrating the deep learning and the machine learning differences. As I stated, that machine learning is having the human intervention, major human intervention, which is providing the classification of the data, whereas we will be having the classification of the data in the deep learning, but it is a layered. So refined data classification or the decision making will be present with the deep learning. So this is how the evolution of the AI is carried out. So previously the rule-based automation was present. So the rule-based automation is like that, where we are defining a certain rules, based upon that that particular activity is carried out over there. For example, if I'll be considering that there are 100 machines are present over there, if I have to configure those 100 machines, so there is a way of configuring those machines. For example, manual configuration will be taking more time. So instead of that, we'll be having the automation which can be used over there. So there are different ways of the automations are present over there. Ansible automation is one of the way by which we are going to configure those machines. So the rule-based automation is going to define the automation concept comes when to reduce the human efforts, and those 100 machines are get spinned or get configured in a less amount of time if the automation is performed over there. So likewise, if we'll take the simple example, the AI and automation and the those human efforts which are present over there. So this is going to define that setting up the particular environment, networking environment, where we'll be going to have the manual efforts as well as the automation. So machine learning, where we are going to train the machines, and then the era of the generative AI is introduced, where we are expecting that based upon the certain prompts we are generating a certain outcome over there. So that is the generative AI. And then nowadays we are having the agentic AI. So these are the different transitions which are happening for the AI, and based upon these transitions, so depending on the applications, now currently we are thinking about the generative AI which can be used. In future we'll be going to use the agentic AI for the automation of the network, but currently usage of the generative AI which is going to define for the 6G technology, so that we will see in the next slide. So that is applicable, so that we are going to see here. So this is give you the overview of the AI, how it is get evolved. The data augmentation. So at certain level, what happens when we will be going to have the data, so along with that original data, certain data has to be generated artificially, and that is going to be used for the analysis purpose. So data augmentation is a technique to solve the problem of limited label data sets in the model training. The idea of the data augmentation is which is going to generate the synthetic data, and it will be increasing the data set, training data set, which will be going to help us for that analysis purpose, predictive analysis or the pattern identification for the data which is floating through the network. So any kind of the application which we want to design, either the predictive analysis we want to perform or the pattern identification of the data, so has to be done. So we require a large amount of the data for the analysis purpose. So not that original data which is present, so that is sufficient. So generating the artificial data, that is synthetic data, is required. So data augmentation is the process of generating that synthetic data. Now we are going to use the that machine learning based or the that deep learning based data augmentation. So that data augmentation is going to be prefer the data which is in large amount, which is relative data, and that is going to be used for the predictive analysis. So high quality and the diverse wireless data is expected for understanding the network nature. So that's why the deep learning, along with the deep learning, the quality of the data and the diversity of the data should be present, so that the deep learning is going to be provide the better quality of the data for the decision making, processing of the data for the decision making. So DL based wireless communication and the networking, data augmentation has been explored to enrich the data characteristics. So that means with the use of the data augmentation, we are going to actually enhancing the quality of the deep learning, so that there will be the better decision making and the analysis can be carried out through the for the network. Now, limitation of the non-AI, that means data augmentation. If we are not going to use the AI for the data augmentation, so we'll be going to have the limited data diversity and the balance. Whatever the data is present with the actual data, so there will be no any major diversity will be present. So that diversity should be generated with the help of the data augmentation, and that we are going to automate it through the AI with the help of the artificial intelligence. Domain specific augmentation is going to be present over there. So now with this limitation, loss of semantic information, so whatever the data is present over there, so that that semantic information is not going to be present with that particular data which is actually generated over there. So that drawback is going to actually provide the way of inefficient mechanism which we are going to provide for the deep learning. So loss of semantic information is another drawback which will be present if we are not going to have the data augmentation uh, through the AI. Limited effectiveness for the large data sets. So whatever the data sets we are having, so as it is a limited and there is no diversity is present, so that will be not going to provide the effectiveness to generate the or to train that particular network environment. So these are the limitations where the data augmentation, if we are going to use, and AI is going to provide the better diversity. So whatever the drawbacks we are seeing here, so those drawbacks will be get avoided with the help of the AI, and that will be generating the artificial data, synthetic data, which can be used for the major analysis. There are different types of these generative AI models which are present over there. So one is the variational autoencoders, which is present. These variational autoencoders is encoding the input data into the latent space and then decoding it back to the original space. So it is compressing the data which is provided as the input data, and that compressed data then again we are going to decode it. So the variety of the data is get generated with this way of the generative AI models. Then the another is the generative adversarial networks, consisting of the discriminator and the generator that are used for generating the data. So the generator generates a new data while the discriminator tries to distinguish synthetic data from the real data. So this is the another way or the model which can have for the data augmentation with the generative AI. Then the generative diffusion models, which consisting of the sampling procedure, where the forward diffusion is carried out and then denoising is carried out. Whereas again we are reversing it to generate the varied type of the data. So diffusion process, reverse diffusion process, and the new data samples will be generated by adding the Gaussian noise. So next is the transformers. The transformers involve self-attention mechanisms. So those are going to transform the data, which is going to learn the complex dependencies and generate the contextual instances. Instances in the sense that the data samples. So these are the 4 different Gen AI models which is going to be used for defining or training the that data augmentation data for analyzing the data or the that network. So using the generative AI models, sorry. Now, this is how we are going to use the generative AI data augmentation on the physical layer. That is the data flowing through the different layers when the networking is there. So if we consider the physical layer, so there is a wireless channel modeling is present and the radio frequency sensing. These are the 2 different components we can consider for generating the data over there in the physical layer. So wireless channel modeling involves simulating the propagation of the electromagnetic waves between the transmitter and the receiver. However, the collecting the real world channel data in the different environments is of generally labor intensive and has high overhead. So generating that kind of the data is requiring more complexity, having the more complexity. So that's why the generative AI can generate a variety of the synthetic channel responses, which allows the creation of diverse training datasets and enhance the performance of the DL based wireless networking. So this kind of the generative AI usage, which is going to provide the better performance and increasing the quality of the training for the deep learning, as the data which is generated along with the original data, a new data is present over there. The samples will be different, and based upon that sample characteristics, we can going to have the variability of the data, and that can be analyzed to identify the patterns or the train that particular data. Classification of the data would be possible. Then the radio frequency sensing is the another way by which we are going to have the usage of the generative AI. Then again, we are having the usage of the Gen AI data augmentation in the network traffic management and the network anomaly detection. So this is how we will be going to manage the different layers with the AI or generative AI models, which is going to be present over there. So if you see that the mechanism which we are going to impose here, we are using the data augmentation. Along with that, we will be going to use how the deep learning and the neural network models which are going to be applied. And with that, these are the different neural network models which is going to be used: convolutional neural network, recurrent neural network, deep reinforcement learning, and graph neural network. So these are the different neural network models are going to be used at the different layers along with the that generative AI models, and which is going to be provide the enhanced mechanism of decision making or the predictive analysis which can be carried out in the network for the network optimization or the network healing, or we can say that the network configuration. So this going to be achieved. Next will be the advantages of the AI native 6G development. So we'll be having the built-in capability to deliver the AI services. We are going to build the 6G technology with the AI services. So AI traffic will be there. So as it is having the AI traffic in the sense that which is going to be used to analyze the network, which is going to use to optimize the network. So that traffic through the AI services will be available and at the edges, and that is going to be the best point which is going to be defined, because the analysis will be get improved. The mechanism which we are expecting for the optimization, for the network optimization, as the data is going to be restricted to the edge, so we'll be going to have the better capability for delivering those AI services. Extreme efficiency across spectrum usage. So whatever the spectrum is available, so we'll be going to use that spectrum efficiently, and that's why the energy consumptions is also get reduced over there. Software defined architecture, so that is another feature of the AI native 6G development. We will be going to have the software defined infrastructure or the software defined the networking can be possible, can be utilized in the 6G development. Enhanced cyber security would be present in the AI native 6G development which we are expecting. So these are the different advantages are expected for the AI native 6G development. The software defined networking is one of the concept which is defined here. So it is a layered structure where we are going to differentiate between the application tier, infrastructure tier, and the control tier. Control tier is nothing but the SDN controller which is present over there. So we are going to separating the application part and the networking component parts. So whatever the applications are interacting, so that will be interacting through the SDN controller, software defined network controller, which is considered as a brain of that software defined networking, and through that we are going to communicate or we are going to operate that particular networking components over there. This is one of the example which I took here for understanding the SDN. That is a big concept, SDN, software development, software defined networking, which is utilized actually in the that networking. So as we see that this is one of the environment which is present over there. In that environment, actually the application is deployed. So pod is deployed over there. So Kubernetes cluster is present. In that Kubernetes cluster, outside world is not going to access to that particular application until and unless it is get exposed. So that is what the software defined network comes into the picture. Until and unless we are going to have the actually software defined networking is decoupling the hardware and the applications over there. So as we are not going to have the softwares which are hardware specific, so we are decoupling that, and through that, if there is a change in the particular specific vendor network component, so that is not going to affect on the mechanism how it is going to be operated over there. So that is what the software defined networking is going to be utilized. Okay, so here the application which is that is one of the web server, nginx server is deployed, and now if I have to access that particular server, it has to be exposed, and that is what I am going to do with the software defined networking. So it is one kind of the application, so utility or the interface we will be generating over there, and through that utility we are going to interact with that particular application. So this is how we will be going to decouple the networking infrastructure, either it is a that hardware. So those hardware, if it is get replaced or it is get changed, so that is not going to affect on the mechanism or the operation of that particular networking if it is defined with the software defined networking. So this is one way by which we are going to decouple that hardware and the software part of the networking. There are different models of the SDNs are available: Open SDN, SDN by APIs, SDN overlay models, and hybrid SDN. So these are the four different models are available for software defined networking. So any one of them can be used for own specific purpose. So that can be utilized for the defining that networking. So benefits of the SDN: enhanced scalability. So though if we are going to add another components, networking components, switches or the routers or any networking components, so it is going to be get scaled with the software defined networking. Better security, as the layered structure will be having, we are going to decouple the hardware and the software parts. So that's why there will be the better security if one of the component get failed. So we are going to differentiate from that network, and whenever it is up, so we'll be going to make it, or if any one of the component is get affected, so we'll be going to decouple it, and that is get operated later on when it will be available. Easy network control. So as with the software defined networking, through only changing the application, that software applications or the software constructs, we can easily manage that particular control, that network. Big data support, whatever the support is expected, so as the data is flowing through, so as the components are get changed or the application interfaces get changed, so still we are going to operate on the data which is floating through the network. Telecommunication modernization: with the software defined network, we are actually modernizing the telecommunication infrastructure. So that is the feature which will be having through the SDN. SDN is actually implemented with the big giants, Microsoft, Google, entity. So those are using this software defined networking with the SDN architecture and the AI supported routing. Routing operations become faster and the more efficient. That will be increasing the network performance and the network management. So as I said that edge computing, which is the part of the 6G technology, edge computing is nothing but the whatever the different devices are present. So what are the operations which you want to carry out? So those operations are maximum not going to be passed to the cloud or the centralized server. So instead of that, we will be going to use it at the intermediary layers which will be present over there. So those intermediary layers which will be near to that particular device, either at itself that device, or we can say that the internet service provider or the routers or the switches or any networking components which is near to that particular user device, so that will be utilized actually for computation purpose, and that's why reducing its time of implementation. Wait a minute. So this is how the edge computing is going to be presented. So edge transportation is one of the application, edge healthcare. So these are the different technologies which we have seen for the AI networking, intent-based networking, AI ops, that is another the different ways. Network digital twins, which is a future for the AI networking. The research initiatives which have been taken in the globe. So ITU, which is associated with the 6G technology, which is which is combining the different, we can say that the service providers, internet protocols, or the standard, which is going to be defining the standard authority, architecture authorities are going to be associated with this ITU to develop the 6G technology. There is a specific work is carried out at the University of the Oulu, Finland, that is mainly focusing on the 6G. Federal Communication of the United States is also working on the 6G. Research challenges, the different data qualities, labeling, and the acquisition across heterogeneous environments is expected. Hardware, whatever the different components are present over there, which are compatible with the 6G, are going to be defined. Reinforcement learning for the spectrum management and the dynamic routing, so that those are the research scope. AI-based mobility prediction in which vehicular and the drone networks, data-driven QoS, QA optimization models. So these are the different research opportunities are present. So I will be concluding this. AI is the catalyst for the innovation in the wireless communication. 6G networks are fundamentally AI natives actually. Edge and the federated learnings are the new features for this 6G technology. Collaboration between AI researchers and the telecom engineers is vital for the industry 5.0. Different references which I utilize for this. Any questions and answers? Sorry, I took more time.
No, sir. No, sir. Sir, thank you very much, sir.
Okay.
Thank you. On behalf of our institution and all participants, I would like to thank Dr. Kiran Gaikwad, sir, for giving us such a useful and engaging session today, sir. Once again, thank you very much, sir. We hope to learn from you again in the future also. Thank you, sir.
Thank you. Thank you so much.
Our dear all participants, we'll continue tomorrow with the next set of expert session as per the schedule. Participants are requested to join the tomorrow's session on Zoom platform 5-10 minutes before itself to ensure the timely attendance and smooth proceeding. Kindly maintain the 75% attendance which is required for certifications. Please fill the attendance link and provide the feedback to today's sessions. Already I shared the links on your WhatsApp group as well as here also. Okay. Thank you all once again. Wish you a pleasant evening and looking forward to your active participants tomorrow also. Thank you very much. Thank you for the participants. I'm closing today's session. Thank you, Kiran sir, and all. Good night, sir. Please fill the feedback form as well as attendance form. The same link is there. Just go through and fill the feedback form. Through that, we will ensure your attendance on ATAL FTP platform. Thank you very much. Good night.